Here we have a SAT math problem. Okay, let's go to the question. If p equals to a square negative 4a positive 8, what is the least possible value of p positive 6? Okay, here we have a quadratic function that is p equals to a square negative 4a positive 8. Okay, for my convenience, let me change the variables. That is for p, I consider the variable y, and for a, I consider the variable x. Okay, now I'm going to plug in this y for p over here and this x for a over here and here. Then we'll be getting the function y equals to x square negative 4x or positive 8. Actually, it is a quadratic function in standard form. That is ax square positive bx positive c. Okay, so whenever we have a quadratic function in this form, that is y equals to ax square positive bx positive c, its graph will be a vertical parabola. And what is the leading coefficient over here? The leading coefficient is the number we have in front of x square. Actually, we don't find any number in front of x square, so we have to assume it's 1. So that is the leading coefficient is 1. It's a positive value. Since the leading coefficient is a positive value, the graph we get for this quadratic function will be a vertical parabola which opens up. So it will look like this. Okay, here when the parabola opens up, the vertex is the minimum point. So that is particularly the y-coordinate, the value of the y-coordinate over here is the minimum value of this function. That is the minimum value of y. Okay, to get the minimum value of y, that is to get the y-coordinate at the vertex of this parabola, first we have to find the x-coordinate at the vertex of the parabola. How do you have to get the x-coordinate over here? For that, there is a formula that is x equals to negative b over 2a. So for that, we have to consider the given quadratic function over here as ax square positive bx or positive c. Okay, here to get the value of b, we have to consider the coefficient of x over here because b is the coefficient of x. So here in our quadratic function, the coefficient of x is negative 4. So we can plug in this negative 4 for b over here. And this negative sign comes in the formula itself. That is negative of negative 4 divided by 2 times a. Actually, a is the coefficient of x square. The coefficient of x square is just 1 in our quadratic function. So we can plug in 1 for a. Then we get x equals to negative times negative is positive. 4 divided by 2 times 1 is 2. Finally, I'm getting x equals to 4 divided by 2 is 2. Okay, now I got the x-coordinate at the vertex of the parabola, but our aim is to get the y-coordinate, which is the minimum value of y in the given quadratic function. Okay, to get the y-coordinate of the vertex, what I have to do is I have to plug in this x-coordinate 2 for x into this function over here. Okay, let me do it. Then we get y equals to 2 square, negative 4 times 2, positive 8. Okay, here y equals to 2 square is 4, negative 4 times 2 is 8, positive 8. Okay, this negative 8 positive 8 will cancel, that is it will become 0. Then we get y equals to 4. Okay, here I got the y-coordinate of the vertex, that is 4. And this y-coordinate of the vertex 4 is the minimum value of y because this point is at the bottom of the parabola. So let me write the stuff over here. Minimum value of y is equals to 4. Actually, y is a variable taken by us. The original variable we have for y is p. So p is a variable actually we have in the given function. So since the minimum value of y equals to 4, then the minimum value of the original variable p is also 4. Okay, let me write the stuff over here. Minimum value of p equals to 4. Okay, if the minimum value of p is equal to 4, then what is the minimum value of p positive 6? For that, we have to add 6 to both sides of this equation. Okay, let me do it. P positive 6. 4 positive 6, then we get p positive 6 equals to 10. Therefore, the minimum value of p positive 6 is 10, and we find this 10 in answer choice D. The correct answer choice for this question is D.